Assalamualaikum warahmatullahi ta'ala wabarakatuh. Today we will continue with chapter 5, Electromagnetic Induction. For this topic, we have 6 questions and then we will discuss the question one by one. Now, we start with question number 1. A wire of length L equal to 0.2 meter moves to the right with a uniform velocity V equal to 0.5 meter per second as indicated in figure 3. If the resistance of the wire is 10 ohm and the magnetic field B equal to 4 Tesla, calculate the induced electromagnetic force in the wire. Okay, so we need to know that electromagnetic force is referred to EMF. So we need to calculate what is the value of the induced EMF for this wire. Okay, so what we need to do is we need to take out the information given. Okay, here the value of length of the wire equal to 0.2 meter, V, velocity of the wire 0.5 meter per second to the right. Okay, and then also given the value of resistance of the wire 4 ohm and magnetic field equal to 4 Tesla into the page. Okay, to calculate the value of EMF induced, so we need to calculate by using the equation for straight conductor. EMF equal to BLV sin theta. Just substitute all the value given. Okay, but please remember, please be careful. We need to determine the value of theta here. The theta is always the angle between B and V. B is into the page and V is to the right. So the angle between B and V is 90 degrees. So we need to substitute the value of theta equal to 90 degrees. Okay, and then, and by using our calculator, we can determine the value of induced EMF is equal to 0.4 volt. Okay, very easy. For question number 2, a 1.2 meter conducting rod rests on metal rail SP and RQ as shown in figure 8. The rod is placed in a uniform magnetic field B equal to 2.5 Tesla perpendicular to the plane of the paper. The rod is pulled to the right at a uniform velocity V equal to 2 meter per second. If the resistance of the circuit PQRS is 6 ohm, determine question number 1, the induced current in the rod, and then you need to calculate the magnitude and the direction of the force required to keep the rod moving to the right at a constant velocity 2 meter per second. Okay, so what we need to state and take out all the information given. L equal to 1.2 meter, B equal to 2.5 Tesla, V equal to 2 meter per second, and R equal to 6 ohm. So what we need to do is we need to take out all the information and refer to diagram again. Okay, here is our diagram. Okay. Now, for question number 1, to determine the induced current in the rod. Okay, by using EMF equal to BLV sin theta, so we can determine the value of induced current. Because the induced current also, the value of induced EMF also obey Ohm's law. So we can say that IR equal to BLV sin theta. Okay, and then substitute the value given, and so please make sure once again we need determine the value of theta, where theta is angle between B and V. For this question, V is to the right and B in the page, and then the value of theta equal to 90 degrees. Okay, substitute the value, and then the value of I equal to 1 ampere. Okay, for the next question, the magnitude of the force. Okay, we need to calculate what is the value of the force. So by using the equation for magnetic force, force required to move the object, move the straight conductor to the right is equal to F equal to FB, where FB equal to BIL sin theta. Once again, substitute the value B. What is B? B is magnetic field. substitute the value of electric current, I, then substitute the value of L, length of the straight conductor. And then theta is angle, for this question is angle between B and L. Okay, look at the angle between B and L. So the angle is 90 degrees. Okay, now we get the answer is 3 Newton. Okay, so how about this direction? The straight conductor will move to the right. So, of course, the direction for and the force is to the right. Okay, for the next question, question 2b. Okay, define or state Lenz law and then define mutual inductance. So we need to know what is Lenz law, and then we need to know. We need to know what is the definition of the mutual inductance. Okay, for the question number 1, okay, Lenz law states that an induced current always opposed in such a direction that is opposed the change producing it. Okay, and then for question number 2, mutual inductance. Mutual inductance is defined as the ratio of induced EMF in the coil to the rate of change of current in another coil. Okay, for the next question, question 2C. A 1000 ton solenoid has a length of 20 cm and cross-sectional area 5 cm square. A coil of 100 ton is wound at the center of the solenoid. Calculate the magnetic flux through the coil if the current 2 ampere flow in the solenoid, and then the mutual inductance of the coil and the solenoid. We look at the solution. Okay, so we need to take out all the information given, and number of turn for the solenoid 1000 turn, number of turn for coil 100 turns, length of the solenoid also given, and then cross-sectional area for the solenoid 5 times 10 power of -4 meter square. Okay, also given from the question, electric current flow in the solenoid is equal to 2 ampere. Okay, then the magnetic flux through the coil equal to the magnetic flux through the solenoid, because the coil is wound at the center of the solenoid. Okay, therefore we can say that magnetic flux for the coil is equal to magnetic flux for the solenoid. Okay, we can calculate the value. Okay, what is the value of magnetic flux for the solenoid? Okay, by using the formula PA cos theta. Okay, substitute the value. Okay, for solenoid, the value of the magnetic field is equal to mu naught N over L times I. Okay, this one is the value of P, magnetic field for the solenoid. Okay, and then substitute the value. What is the value of mu naught? Number of turn, electric current, length times the value of A cos theta. Okay, so theta is referred to angle between B and A. So the angle between B and A is equal to 0 degree. Then we got the answer is 6.8 times 10 power of -6 Weber. For the next question, the mutual inductance of the coil and the solenoid is M, mutual inductance, equal to mu naught NS NC A over L. Okay, substitute the value given. Okay, what is the value of permittivity? Okay, the value of mu naught. 4 pi times 10 power of -7. Number of turn for solenoid. Number of turn for coil. A is referred to cross-sectional area and L is referred to length and length of the solenoid. Okay, substitute the value, and then we got the answer is 3.14 times 10 power of -4 Henry. Okay, for question number 3, three identical helical springs X, Y, and Z are fixed to two parallel insulated metal rods P, Q, and RS as shown in figure 2. The distance between the two rods is 2 cm and the length of each rod is 40 cm. A current of 30.0 ampere flow through each rod in the same direction. Okay, when the question said that electric current flow in the same direction, so we need to know that attractive force will exist. Okay, so now we need to calculate the force experienced by each spring. Okay, for the solution, take out all the value given. L equal to 40 times 10 power of negative 2 meter. D equal to 2.0 times 10 power of negative 2 meter, and I electric current equal to 30.0 ampere. Okay, this is the diagram related to the question. Okay, electric current flow in the same direction. Okay, so attractive force will exist. Okay, for wire X, okay, we will have Fx. For wire Y, we will have Fy, and for wire Z, we will have Fz. Okay, total of force exerted on the system is equal to Fx plus Fy plus Fz. And we need to know that the value of Fx equal to Fy is equal to Fx equal to F. So we consider the value is F. Okay, because the spring is in parallel, so we need to total up the value of forces acting on the system. So we will got the value of 3F. From the figure, the force F1 is balanced by the resultant force due to spring is equal to total of force acting on the spring. Here. The force experienced by each spring is equal to 3F equal to mu naught I1 I2 L over 2 pi d. But the value of I1 and I2 is the same, so we can state as I power of 2. Okay, substitute the value given, then we got the answer for force acting on each spring equal to 1.20 times 10 power of negative 3 Newton. For question number 4, an inductor of self-inductance 3.0 millihenry is connected to a direct current source which supplies a steady current of 2.8 ampere. Question A, what is the energy stored in the inductor? So we need to calculate what is the value of energy. And the symbol of the energy is U or E. And then B, if the current increase at rate 12.0 ampere per second, what is the induced EMF in the inductor? Okay, now that we discuss, let's discuss the. Okay, given from the question the value of inductance, self-inductance L 3.0 times 10 power of negative 3 Henry and I equal to 2.8 ampere. The energy stored in inductor U is U equal to half Li square. L is given, substitute the value, and then the value of I also given, and then we got the value of U equal to 1.18 times 10 power of negative 2 joule. Okay, so we need to know that the energy is stored in the inductor in form of magnetic field. Okay, B given di over dt equal to 12.0 ampere per second. We need to calculate the induced EMF. Induced EMF is equal to negative L di over dt. L is given from the question, given earlier, 3 times 10 power of negative 3. So just substitute the value of L, and di over dt also given from the question. Di over dt also given. Then we got the answer is negative 3.6 times 10 power of negative 2 volt. Okay, for the next question, question number 5. Okay, this is the diagram given. A copper rod of mass 0.08 kilogram and length 0.20 meter is attached to two thin current carrying wire, as shown in figure 3. The rod is perpendicular to a uniform magnetic field of 0.60 Tesla. Determine the magnitude and direction of the electric current to keep the copper rod fixed and stay horizontal. Okay, now solution. Okay, from the question, mass of the rod is given 0.08 kilogram, and then L, length of the rod, is also given, L equal to 0.20 meter, and magnetic field equal to 0.60 Tesla. Okay, this is the diagram related with the question. Okay, from the diagram, we know that weight of the rod is always directed downward. Okay, and then to balance the weight, force or magnetic force will exerted upward. When the value of magnetic force exerted upward, and then magnetic field is into the page. From the diagram here, B is the X, B is into the page because the symbol is cross. Okay, so we can determine the value direction of I by using our left flaming left hand. Okay, now we calculate first. From the concept FB equal to FG, FB equal to BIL sine theta. Theta is 90 degree because that one is referred to angle between B and L. Then equal to mg. Okay, substitute the value. So we got the value of I is equal to 6.54 ampere. Okay, how about the direction of I? By using our flaming left hand rule. Okay, so our thumb will refer to the force. Okay, magnetic field for the second finger. Okay, jadi itu menunjukkan B into the page, and then we will got the direction of electric current flow is to the right. Okay. Okay, for the last question, question number 6. An AC generator consists of a coil of 30 turns with cross-sectional area 0.05 meter square and a resistance 100 ohm. The coil rotates in a magnetic field 0.50 Tesla at a frequency of 20.0 Hz. Calculate maximum induced EMF and then maximum induced current. Question for A. Okay, take out all the value given and number of turns equal to 30 turns. Cross-sectional area A 0.05 meter square, R equal to 100 ohm, B 0 magnetic field, B is magnetic field, the symbol for magnetic field B here equal to 0.50 Tesla, and S equal to 20 Hz. Okay, for maximum induced EMF, the formula is NBA omega. The original formula is for induced EMF is induced EMF is equal to NBA omega sine theta. EMF induced will maximum if sine theta equal to 1. So EMF maximum, the formula now is NBA omega. So this is the formula. Okay. Substitute the value. What is N? What is B? What is A? And what is omega? Angular frequency. Angular frequency equal to 2 pi F. F is given from the question. Okay, substitute the value now. Then we got the answer is 94.2 volt. Okay. Question B. EMF induced also obey Ohm's law. So by applying the Ohm's law, EMF maximum equal to I maximum times R. Therefore, I maximum, substitute the value, I maximum will become 0.942 ampere. That's all for now. Thank you. Bye-bye.